You are what you eat. We've all heard the saying, and my PhD is looking at whether there's any truth behind that statement or not. And one way to do it is to look at organisms that have a common ancestor and have evolved to have very different diets. So you can think of bears. You've got your vegetarian panda bear and your carnivorous polar bear. Unfortunately, I don't get to work on bears. There's not really enough data available. And instead, I work on a type of parasite that's only one cell. But the idea is exactly the same. I have those that break down sugars and those that break down proteins to get their energy. And this difference in diet is really important, as what you eat is what you use to build the different components of your cell. And one really important component of your cell is your DNA. So DNA is the information store of the cell, and it's encoded by 4 letters, A, T, C, and G. The building blocks that you require to make those 4 letters differ, however. And in particular, they differ in the amount of nitrogen that they require. So what's the problem, you say? Nitrogen's really abundant. It's in the air all around us. Yes, it is, but some organisms really struggle to get hold of enough of it. And that's what brings me back to diet. So your diet, if you're breaking down sugars, gives you carbon and gives you energy. But if you're breaking down proteins, you get carbon and you get energy and you get nitrogen. So you can begin to see how this difference in diet is altering the very elements that are available to these organisms to build the different bits of their cells. And one really cool thing about DNA as a thing to study is that it's quite flexible. So I told you it's the 4 letters. Well, the order of those letters is very important, but because of the way that DNA is read, it's read in blocks of 3. And there's a bit of flexibility, a bit of redundancy, and often that final letter, it doesn't really matter which one it is. So this means that you can change that letter depending on what's available to you. And when I compare the same stretches of DNA in my organisms that have nitrogen from their diet and those that don't, I see exactly that. The ones with no nitrogen in their diet use the letters that require less nitrogen to build than those that have a lot of nitrogen coming from their diet, which is really cool. But even more than that, this difference is so profound that I can actually predict what an organism is eating based purely on its DNA, which has all sorts of implications, as a lot of these organisms are very difficult to grow. So, rather aptly in time for dinner, I can tell you that yes, you are what you eat, and I can tell what you eat from your DNA, but only if you're a single-celled parasite. Thank you very much.